Hello friends, a warm welcome to yet another interesting session on instrumentation and control in power plant industries. In our previous session, we have covered the segregation of various types of flow meters based on their principle of measurement like velocity type flow meter, variable area flow meter, differential pressure flow meter, and mass flow meter. Also, we have discussed about types of velocity flow meters, that is electromagnetic flow meter, ultrasonic, turbine, and vortex flow meter. Also covered electromagnetic flow meter in details in our second session. In this video, we will be discussing about ultrasonic flow meters in details. The word sonic refers to sound and specifically to sound waves. If we look at the sound spectrum, we can split the sound spectrum basically into three parts. The audible frequencies or acoustic sound, which we human beings can hear, is in the range of 20 Hz to 20 kilohertz. Below these frequencies, that is less than 20 hertz, are called infrasound or infrasonic. Animals like elephant communicate with each other in this frequency range. Frequencies above 20 kilohertz are called ultrasound or ultrasonic. Although we humans cannot hear these frequencies, but play a significant role in medical and other scientific work. Bats, submarines, etc. use these sound waves to sense any obstruction ahead. They transmit ultrasonic waves. In case of any obstruction ahead, the waves strike and come back. This way, the presence of obstruction along with its distance, position, its coordinates is calculated. This frequency range goes up to 200 megahertz. Above 200 megahertz are called hypersonic. Ultrasonic flow meter is very useful due to their high accuracy in pipelines with very big diameters, say 500 mm dia or 1 meter dia or 2 meter dia, where other flow meters like orifice, vortex or turbine flow meters are not very accurate. Ultrasonic flow meters are of two types. One is transit time or time difference ultrasonic flow meter. It is used when fluid does not contain any solids. And second is working on Doppler's effect and is useful in fluids containing particles or bubbles. First, we will discuss about transit time or time difference type ultrasonic flow meter. To understand the concept of ultrasonic flow meter, let us look at the following diagram. On top side and bottom side of the pipeline, basically we have one bigger diameter pipeline, and on top side and bottom side of this pipeline, two transducers are mounted at about 45-degree inclined to the pipeline. These transducers are basically piezoelectric crystals connected through changeover switch to one side electronic oscillator that generates ultrasonic waves, and on other side it's detector which senses the ultrasonic waves. So both these transducers are basically capable of transmitting as well as receiving ultrasonic waves, but only one type of action at a time depending upon the changeover switch position. If no flow is there in the pipeline, the one transmitter will be transmitting and second will receive, and then second will be transmitting and first will receive. In both the cases, as there is no fluid flowing through the pipeline, the time taken by the waves from transducer A to transducer B is same as the time taken by the waves to travel from transducer B to transducer A. Clear? Now, as the transducers are installed inclined to the pipeline in opposite side facing, so definitely one transducer will be transmitting in the direction of the fluid flow, while while the other will be transmitting against fluid flow direction. Here, fluid flow in our example is from left to right, as shown in the figure. So our transducer A is transmitting with flow direction, and transducer B is transmitting against flow direction. Thus, it's clear that time for the wave to travel from B to A will be higher than the time for the wave to travel from transducer A to B, because one is against the transducer and against the fluid flow, and second one is with the fluid flow. The time difference between the two is calculated as time B to A minus time A to B. In both the cases, the transmitter is transmitting the same frequencies. Thus, the time difference is only due to fluid flow. Clear? As the fluid flow rate is increasing, this time difference is also increasing, and vice versa. The delay in time is directly proportional to the fluid velocity, and we can say is directly proportional to the fluid flow rate. As, as the sensors do not have any moving parts, the maintenance cost is very low, no pressure drop, and the measurement accuracy is high. Our second type of ultrasonic flow meters are Doppler effect flow meters. The Doppler effect flow meter is used when fluid contains particles or bubbles. Doppler effect is nothing but when the ambulance passes through the road, the siren sound will be high when the ambulance is near, and the sound vanishes as it goes away. This happens even the siren sound remains the same. This is called Doppler effect. The same effect is used in the Doppler effect ultrasonic flow meters. It contains only one sensor which has both transmitter and receiver. The transmitter will emit the ultrasound waves. Due to the particles in the fluid, this ultrasound wave will reflect back to the sensor. The receiver will receive the wave but with a different frequency. The frequency shift is directly proportional to the fluid flow rate. Based on their installation, ultrasonic flow meters can be divided into three parts. One is inline, second is clamp-on, and third is combined. Inline we have already discussed throughout this discussion. Clamp-on, which is used when we need no interaction of the fluid with the flow meter. This meter will measure flow rate with little less accuracy because it is mounted outside the pipe. Before buying such clamp-on meters, we need to know about the pipe wall MOC, that is the material of construction of the pipe, and the thickness. There is one another which is combined flow meter, which has both inline as well as clamp-on to achieve maximum accuracy in the measurement. Regarding the precautions while installing ultrasonic flow meters, pipe must be full of liquid that is uniform and easy for ultrasonic pulse to travel through. Avoid installing the transducer at the highest point of the pipe system or on the vertical pipe with free exit. For the open pipe, the transducer should be installed at the bottom of the U pipe. Regarding straight pipe length requirements, uh, we can say the longer is the better. The straight pipe length should be long enough to eliminate irregular flow induced error. Let us say D is the pipe outer diameter, then the transmitter should be installed at a pipe section where the length of the straight pipe on the upstream side is at least 10D and on the downstream side at least 5D. One more thing to remember, ultrasonic transducer installation should be at least 30D away from a pump discharge. Advantages, definitely they have many advantages. They don't have any moving parts, no obstructed flow path, no pressure drop, highly accurate, highly effective for large pipe diameters where other flow meters may not be accurate enough. Our Doppler type flow meters is ideal for aerated liquids such as wastewater and slurries, whereas our transit time ultrasonic flow meters are ideal for clean liquids applications such as water and oil. It has certain disadvantages too, like expensive as compared to others, and that can impact the performance. So friends, this was all about ultrasonic flow meters, their principles, their application, their limitation, and their specific installation requirements. Hope I am able to clear the concept well. We will meet you in our next video. Till then, stay safe, stay healthy. Bye.